Welcome to this quick guide for the Dubai Municipality G+4 Steel Construction Contracting Exam. This session highlights the core structural steel topics essential for G+4 licensing success. In this presentation, we will cover essential concepts in steel construction for G+4 licensing, including connections, beams and members, stress limits, deflection rules, and slenderness. We will also delve into SFD and BMD diagrams, foundations, base plates, and Dubai Municipality Code requirements and key standards. Understanding steel properties and grades is essential in structural design. Structural steel has a high stiffness with an elastic modulus of 200 gigapascals and a density of 7,850 kilograms per cubic meter, 78 kilonewton per cubic meter, used for dead load calculations. The Poisson's ratio is 0.3, and carbon content is limited to 0.6% to maintain ductility. Common grades include S235, S275, 275 megapascals, S355, 355 megapascals, and A992M, 345 megapascals. High-strength steels start from 460 megapascals and are used in heavy load structures. These values are frequently asked in exams and are vital for code-based design. In structural steel design, allowable bending stress is limited to 0.665, ensuring members don't yield under service loads. Shear stress is typically limited to 0.40 to 0.455, and bearing stress is capped at 0.755 for safety. For concrete and bearing, a typical allowable stress is 3 to 4 Newton per square millimeter. Regarding deflection, general beams should not exceed L by 325 of the span. For live load, deflection limits range between L by 250 to L by 325, while cantilever beams must be checked more strictly, L by 180 to L by 240. For single-story columns, horizontal deflection is usually limited to L by 325. These values are often directly asked in the DM exam, so they must be memorized. Structural bolts are classified by grades based on strength. Grade 4.6 bolts have an ultimate tensile strength of 400 megapascals and yield strength of 240 megapascals, while grade 8.8 bolts offer much higher strength, 800 megapascals ultimate and 640 megapascals yield. Grade 8.8 bolts must be marked with the manufacturer's ID and grade. Common bolt sizes used in steel construction include M16, M20, M24, and M30. The net tensile area is considered as 0.78 times the nominal shank area, accounting for the threads. Bolt holes are typically made 1.5 to 2.0 millimeters larger than the bolt diameter to allow clearance. For design, the partial safety factor gamma MB is taken as 1.25 according to code requirements. These values are commonly tested and must be memorized. In bolted connections, proper spacing ensures structural integrity and avoids failure. The minimum pitch, center-to-center distance between bolts, must be 2.5 times the bolt diameter, 2.5 d, while the maximum pitch in tension members is limited to 16 times the plate thickness, 16 t, or 200 mm, whichever is less. Edge distance should be between 1.5 d to 2.5 d, for example, with an M20 bolt, the minimum edge distance is 50 mm. For high-performance joints, HSFG, high-strength friction grip, bolts are used. They transfer load through friction, not bearing, and are ideal for fatigue-prone structures. They provide no-slip connections and are tightened to a snug tight condition, ensuring the plies are in firm contact. These details are often tested in DM exams. In steel construction, the fillet weld is the most commonly used type, especially for beam-to-column connections, and must not be smaller than 3 mm in size. Butt welds are used to join plates end-to-end in the same plane, while groove welds are typically used in high-strength structural connections requiring full penetration. For quality control, non-destructive testing, NDT, methods are used. Visual inspection is the first and most routine check, ultrasonic testing detects internal flaws, and liquid penetrant testing, LPT, helps identify surface cracks in the weld. These tests ensure weld safety and compliance with AWSD 1.1 standards, which is critical for passing inspections and exams. In beam design, the effective span is measured between the centers of supports, and the most efficient section for bending is the I section, due to its high moment of inertia. Shear forces are primarily resisted by the web, and to prevent lateral torsional buckling, adequate lateral support must be provided. For columns, the key design parameter is the slenderness ratio, LR, where buckling is the primary mode of failure in compression members. Column base plates are designed to distribute axial loads evenly onto the foundation, with a typical bearing pressure limit of 4 Newton per square millimeter on concrete. According to the Dubai Building Code, the minimum wind pressure to be considered in structural design is 1.0 kN per meter. For protected steel elements, the acceptable thermal variation range is plus or minus 20 degrees C. In severe environmental conditions, the minimum thickness of steel sections must be at least 6 mm, including for plates used in built-up sections. Regarding dynamic behavior, structural damping should be taken as 1% to 1.5% under serviceability conditions, and 1.5% to 2% during strength design. These values are essential to meet code compliance and are often included in exam questions. For pile design and compliance with the Dubai Building Code, a minimum safety factor of 2.5 is required. Pile spacing should be at least 2.5 times the pile diameter, and the maximum allowable compression stress on piles is limited to 25% of the concrete's compressive strength. Each pile must have at least 6 reinforcement bars evenly spaced for structural integrity. In high-rise buildings, above G+12, a minimum of 4 to 5 boreholes is required, with a borehole density of 1 per 750 square meters. For anchor systems, maintain at least 1.2 meters between anchors, and for tension piles, the maximum allowable crack width is limited to 0.1 millimeters. Understanding shear force diagrams, SFD, and bending moment diagrams, BMD, is critical in structural steel design and frequently tested in the G+4 exam. For a simply supported beam with a central point load, the SFD shows a sudden drop at the load point, and the BMD has a maximum value at mid-span, calculated as WL/4. For a uniformly distributed load, UDL, the SFD is a straight line, and the BMD forms a parabolic curve with the maximum moment at the center as WL²/8. In cantilever beams, the SFD and BMD are highest at the fixed end, with triangular and parabolic shapes, respectively. The maximum bending moment always occurs where shear force is 0. Practicing these basic cases helps in quickly solving numerical questions under exam conditions. For structural design, certain basic calculations are frequently required. The slenderness ratio for columns is calculated as lambda equals LR, where L is the effective length and R is the radius of gyration. Bolt spacing should meet a minimum of 2.5 GA, and a maximum of 16 tons or 200 mm, while edge distances should fall between 1.5 GA and 2.5 GA. The net tensile area of a bolt is typically taken as ANB equals 0.78 times ASB, gross area. Key material properties include E equals 200 gigapascals, density equals 7,850 kilograms per cubic meter, and Poisson's ratio, nu, equals 0.3. For design safety, use gamma MW equals 1.25 for shop welds and 1.5 for site welds, while gamma MB equals 1.25 applies for bolt design. To succeed in the G+4 steel exam, focus on key topics like bolt types, spacing rules, SFD/BMD numericals, beam stress limits, and foundation basics. Memorize Dubai code values such as atom plate thickness and standard steel grades. Boost your preparation by practicing with Xiape's mock tests and downloading the sample McQ sets to improve speed and accuracy. Thank you for joining us in this presentation. We wish you the best of luck in your G+4 exam preparation. If you have any questions, feel free to reach out to us. Don't forget to download sample McQs to aid your study.